Hello dear students, you are all welcome to today's e-learning class in chemistry. Today we will be continuing with the same topic, that is aldehydes and ketones. In last class we had discussed some basics, some fundamentals about aldehydes and ketones. Its definition, classification, nomenclature, structure and isomerism. So, today we will discuss about some important preparations, and before going to discuss about preparations, let us discuss some important things, that is the similarities between a carbon-carbon double bond and a carbon-oxygen double bond, that is olefinic double bond and a carbonyl double bond. What is the similarities? And then we will discuss about the dissimilarities. After discussing these two things, we will go to discuss in detail about general methods of preparation. So, what are the similarities between olefinic double bond and a carbonyl double bond? यहाँ भी double bond है और वहाँ भी double bond है. What are the similarities? So, similarities are like this. Both contains a double bond, means there is one sigma bond and one pi bond. You know, in each case a double bond always composed of one sigma and one pi bond. Both are same in both the compounds. Second, in both the cases, in olefinic double bond, the two carbon atoms are sp2 hybridized. Here, the carbon and oxygen are also sp2 hybridized. Their hybridization state is the same. Okay? And they have a planar structure, trigonal planar, with a bond angle of almost about 120 degree. Okay? And both of them undergo addition reaction. Double bond है मतलब वो addition reaction ही होंगे. They will show addition reactions, right? So, these are the similarities. What are the dissimilarities? They show addition reaction. It is okay, but what type of addition reaction? Carbon-carbon double bond, that is alkene, shows electrophilic addition reaction. It is its characteristic reaction. What about carbonyl compounds? The carbonyl compounds show nucleophilic addition reaction. Olefinic double bond is non-polar, no positive, no negative charge. Here it is polar. Oxygen develops partial negative charge and carbonyl carbon develops partial positive charge, and it is the reaction site. सारी की सारी रिएक्शन वहीं पे होते हैं. नेक्स्ट, olefinic double bond shows unsaturation test. Carbonyl compound does not show unsaturation test. That means alkenes are unsaturated, aldehydes and ketones are not unsaturated. So, they show unsaturation test. What is unsaturation test? It is a test to determine whether organic compounds contain any unsaturated bond between carbon and carbon. That is, if any pi bond is present between two carbon atoms, the test that is carried out to know this is called unsaturation test. What is that test? Do you know? If you add bromine solution in carbon tetrachloride, remember, if you add bromine solution in carbon tetrachloride or alkaline potassium permanganate solution, the color will be discharged. The reddish brown color of bromine will be discharged or pink color of potassium permanganate will be discharged. If color is discharged, that means it is unsaturated. Alkenes show such tests, but carbonyl compound does not respond to unsaturation tests. Important difference. Alkenes show ozone-lysis, but carbonyl compound does not undergo ozone-lysis. So, these are the differences. It may be asked in the examination. So, let us go to discuss about general methods of preparation. So, first method of preparation is your oxidation of alcohols. Oxidation of alcohols, very important, very important. You know, the oxidation of alcohols are done by two types of oxidizing agents. Type 1 oxidizing agents Type 1 oxidizing agents are strong oxidizing agents like potassium permanganate, acidified potassium permanganate or alkaline potassium permanganate, potassium dichromate, acidified solution, or even your chromic acid, or you can have concentrated nitric acid. These are all strong oxidizing agents. Type 2 oxidizing agents are your mild oxidizing agents like PCC, PDC, Collins reagent. These are the reagents I have already discussed in alcohol chapter. Collins reagent. You just see, I am taking primary alcohol RCH, here HOH. So this is called alpha cleavage. Oxidation of alcohol means alpha cleavage. What is alpha cleavage? Remember, this is alpha carbon because functional group is bonded to this carbon. This is alpha carbon, and the oxidizing agent, strong oxidizing agent, provides oxygen here. You can take potassium permanganate or any acid. ठीक है? So this bond breaks, alpha carbon hydrogen bond breaks, oxygen hydrogen bond breaks, then two hydrogen combines with the oxygen, they form water. Okay? This bond breaks means a double bond is formed here. Remember very carefully, this bond breaks means a double bond means a pi bond is formed here. We get aldehyde, right? Plus water. In this way, primary alcohol gives you aldehyde containing same number of carbon atom. बात तो यहाँ तक ठीक है, कोई प्रॉब्लम नहीं, कोई दिक्कत नहीं, कोई परेशान नहीं. लेकिन परेशान की बात ऐसा है, प्रॉब्लम तब आती है when you see the aldehyde immediately combines with the water in presence of acid, it forms your hydrated aldehyde and it remains in equilibrium with this hydrated aldehyde. So aldehyde on reaction with acid in presence of reacts with water in presence of acid or alkali, it makes its hydrated form. This hydrated aldehyde remains in equilibrium with the aldehyde. Then this molecule is highly unstable. It undergoes further oxidation to give you carboxylic acid. Because you see, this is OH, and this H undergo further oxidation to give you OH. And you know, if three OH groups are bonded to a single carbon, it becomes highly unstable. Immediately it loses a water molecule and give you acid. In this way, aldehyde undergoes further oxidation to give you carboxylic acid. यहाँ तक तो ठीक था. प्रॉब्लम यहीं से शुरू हुआ जब वाटर मीडियम में देखने को मिला. Because we are using the reagents in aqueous medium, so this water in presence of acid forms hydrated. This molecule is responsible for formation of carboxylic acid. रिएक्शन यहाँ रुकने वाला नहीं है. ये जो रिएजेंट है ये रिएक्शन को यहाँ रोकने नहीं देगा. सो हाउ दिस प्रॉब्लम विल बी सॉल्व्ड? तो गड़बड़ी यहीं पे, और कर रहा है कौन? वाटर कर रही है. इसीलिए दिस प्रॉब्लम इज सॉल्व्ड बाय यूजिंग PCC, PDC or Collins reagent. Do you know these reagents? They are all complex compounds of chromium in pyridine, and they are using aprotic, non-protic solvent or non-aqueous solvent like dichloromethane. ये जो solvent है इसमें वाटर नहीं है. तो अगर वाटर यहाँ सारी की सारी समस्या की जड़ है तो यहाँ उसको हम रिप्लेस कर देते हैं बाई CH2Cl2 dichloromethane. That is why the problem is solved. That means aldehyde can no longer form its hydrated form and a reaction can only proceed up to this stage. ठीक है. So PCC means pyridinium chlorochromate or pyridinium dichromate or Collins reagent, उन सभी की सब reagent की काम एक ही है, तो रिएक्शन को यहीं पे रोक देते हैं बिकॉज दे डोंट कंटेन इन वाटर, ये दो हाइड्रेटेड एल्डिहाइड नहीं बनेगा और फर्दर ऑक्सीडेशन होके एसिड नहीं बनेगा, ठीक है। तो अगेन देयर इज सम प्रॉब्लम हियर, we thought using Collins reagent PCC or PDC problem is solved, means alcohol, primary alcohol gives you aldehyde because we want only aldehyde, but thing is that it is chromium metal, it is also toxic, ये टॉक्सिक मेटल है, टॉक्सिक कंपाउंड, और आप जानते हैं कि टॉक्सिक कंपाउंड के साथ काम करना कितना खतरनाक होता है। इट विल बी ऑल्सो इक्वली डेंजरियस फॉर द वर्कर्स and also equally dangerous for the compound because it will make the product poisonous, ठीक है। It can be sorted out by using another suitable reagent, that reaction is called Swern oxidation, and the reagents used are dimethyl sulfoxide DMSO and oxalyl chloride. This is your oxalyl chloride and a triethylamine. This is your triethylamine. So by using these reagents, we can also get your aldehyde. Nowadays these reagents are widely used. So you can also use these reagents and also can use these reagents, right? Next, let us proceed to discuss about one more thing. Similarly, secondary alcohol will give you ketone because this H, they are removed as a water on reaction with either a strong oxidizing agent or mild oxidizing agent or with DMSO, oxalyl chloride or triethylamine, that is Swern's reaction. So it will give you ketone, ठीक है। And a tertiary alcohol is highly stable and it does not respond to this oxidation because it does not contain any alpha hydrogen. Tertiary alcohol does not respond to this test. Next is your catalytic dehydrogenation. Catalytic dehydrogenation is also that we have already discussed in alcohol chapter. Same thing, it is also a kind of oxidation, but it gives you aldehyde and ketone. Like you see, primary alcohol when heated with reduced copper at 300 degrees Celsius, only hydrogen is lost here. This alpha carbon hydrogen and oxygen hydrogen bond breaks and we get aldehyde. Similarly, in case of secondary alcohol, here there is no oxygen or nascent oxygen supplied by any oxidizing agent. When you heat it with reduced copper at 300 degrees Celsius, you get ketone, right? If you take tertiary alcohol, I have already discussed it when heated with reduced copper at 300 degrees Celsius, instead of a dehydrogenation, it undergoes dehydration to give you alkene. This is the difference in reaction between primary alcohol, secondary alcohol and tertiary alcohol with reduced copper at 300 degrees Celsius. What are the questions being asked in CHEC examinations for last 10 to 20 years? These are the questions frequently asked. Let us have a look what are the questions being asked or likely to be asked in this year examination. How will you convert ethyl alcohol to acetaldehyde? Now you answer. You can use here PCC or PDC, or you can write Swern's reaction. What happens when ethyl alcohol is treated with acidified KMnO4 solution or ethyl alcohol is heated with the reduced copper at 300 degrees Celsius, or it is heated with or treated with your PCC. Just you tell the reactions. Or how will you prepare ketone from isopropyl alcohol? How will you prepare acetone from isopropyl alcohol? So you just give the answer. So it is your acetal, it is your acetic acid because it undergoes complete oxidation. It is your acetaldehyde, and this is also your acetaldehyde. In this way, questions are being asked in CHCC examination. I am hopeful you can be able to answer all the questions after seeing this from this discussion. Okay. Now let us start the third method of preparation. Very, very important. So many times it has been asked in CHCC examinations that by dry distillation of a calcium salt of a carboxylic acid, by dry distillation of a calcium salt of a carboxylic acid, how will you get calcium salt of carboxylic acid? If you take carboxylic acid and do reaction with the calcium hydroxide, so this is acid and base, so this is acid, this is base, you can also get calcium salt of a carboxylic acid. Okay. And when there are three important parts. When you heat the calcium formate, this is your calcium formate. When you heat calcium formate very strongly in a distillation apparatus, this is calcium formate. Okay. Let me make it write it very clearly. So this is calcium formate. When you heat it very strongly in a distillation apparatus, you see the bond breaks here like this. You just know, so you should know how to write it or how to draw the structure so that the product can be obtained. So this is, if this forms CaCO3, calcium carbonate is eliminated and we get formaldehyde. So this is the suitable method for preparation of only formaldehyde. So this is formaldehyde and a calcium carbonate, right? If you take any other aldehyde, calcium salt of any other carboxylic acid, if you take calcium salt of any other carboxylic acid other than formic acid, this is calcium formate, this is calcium carboxylate. You can have a calcium acetate, calcium propionate, you can take any kind of a calcium salt. So it is not H. When you dry distill it, strongly heat it, you will get ketone. And a calcium carbonate. If you take calcium acetate, so many times it has been asked, what happens when calcium acetate, if you take CH3 in place of R, you have to take similar groups. What happens when calcium acetate is dry distilled? Here CH3, that means you will get acetone. When calcium acetate is dry distilled, we get acetone, right? When you take a mixture of, this is very important, when you take mixture of or heat mixture of a calcium formate or calcium carboxylate, this is calcium carboxylate plus calcium formate. So this is a calcium formate. So many times it has been asked in examinations. What happens when calcium carboxylate, right, is heated with the calcium formate? So this is formate. What will be the product? Never write that you will get acetone or aldehyde. You will never get aldehyde as single product because you are not taking the isolated single molecules. हम यहाँ से कुछ कैल्शियम कार्बोनेट ले रहे हैं, इसका मतलब उससे कई सारे मॉलिक्यूल्स हैं, इसके अंदर भी कई सारे मॉलिक्यूल्स हैं, तो क्या होगा ना, ये कैल्शियम कार्बोक्सिलेट, ये दे विल अंडरगो, ये मॉलिक्यूल it will undergo dissociation within itself and it will give you ketone, right? It will give you ketone. And this molecule, calcium formate, it will also undergo decomposition within itself, give you formaldehyde. So this is your ketone, this gives you ketone, it undergoes decomposition like this and it also undergoes decomposition like this gives you formaldehyde and ketone. And when they are crossed, means when they are crossed like this, so RCO combined with HH, that will give you aldehyde. That means, this is very important, you will get a mixture of three products. From this one you get ketone, from this one you get aldehyde, और दोनों जब combine करते हैं हमको मिलेगा other aldehyde. So means ketone plus formaldehyde plus other aldehyde. तो ये रहा problem. You cannot get isolated aldehyde except formaldehyde. ये रहा इसी प्रोसेस का लिमिटेशन. ठीक है. नेक्स्ट वन इज योर अनदर इंपॉर्टेंट रिएक्शन इज योर रोजेनमॉन्ट्स रिडक्शन. रोजेनमॉन्ट्स रिडक्शन very very important. In this reduction, acid chlorides undergo partial reduction in presence of palladium supported over barium sulfate. Very important, deactivated or poisoned by sulfur or quinoline. In xylene medium they give you only aldehyde. Partial reduction होके वो बनाते हैं aldehyde. If they undergo complete reduction, you know, if they undergo complete reduction means again 2H will be added here or H2 will be added here, you will get RCH2. Here 1H will be added, here 1H will be added, and you will get a primary alcohol. You will end up in getting primary alcohol. So reaction को यहीं पे रोकना पड़ेगा, इसलिए उसको partially reduction करेंगे. How? ये जो palladium catalyst है, it absorbs hydrogen gas sufficiently. So therefore it is necessary to deactivate its surface. How? By using sulfur or quinoline. ये दोनों का काम है. उसके ऊपर में जो एक्टिव साइट है, it blocks large number of active sites on its surface and decreases the concentration of hydrogen. अगर हाइड्रोजन की मात्रा कम हो जाती है तो रिडक्शन कंप्लीट नहीं हो पाएगा, तो यहीं पे रिएक्शन खत्म होगा, तो आल्डिहाइड मिलेगा. वही तो हम चाहते हैं. अगर कंप्लीट रिडक्शन हो गया, उसको प्रॉपर्ली डीएक्टिवेट नहीं कर पाए, तो यू विल गेट प्राइमरी अल्कोहल. एग्जाम में कई बार पूछा गया, जैसे हाउ यू प्रिपेयर, कई बार पूछा गया हाउ यू प्रिपेयर आल्डिहाइड फ्रॉम कार्बोक्सिलिक एसिड इन 2 स्टेप्स. हाउ यू प्रिपेयर aldehyde, how you prepare aldehyde from carboxylic acid in 2 steps? Do you have any answer? Yes, come on. इससे हमको aldehyde कैसे मिलेगा, ये दे दिया 2 steps में पूछा गया. पहले क्या करेंगे ना, you react it with SOCl2, you convert it to RCOCl, you make it acid chloride. ठीक है. ये then you react it with hydrogen or palladium, barium sulfate, sulfur or quinoline. This is also called as Lindlar's catalyst. Lindlar's catalyst. In place of writing, instead of writing all these reagents, you can also write Lindlar's catalyst. You will get aldehyde. How will you prepare ketone? Yes, you can also prepare ketone from the same acid chloride by using 2 reagents. Here, if you add dialkyl cadmium, R prime मैंने लिख दिया थोड़ा डिफरेंस जानने के लिए. ठीक है. You will get, when you are using dialkyl cadmium, remember you have to take 2 molecules because here there are 2 chlorine groups. So 2 alkyl groups will be substituted with the 2 chlorine groups. These will be replaced by alkyl groups. So you will get 2 molecules of ketone, right? You can also employ another reagent, alkyl cadmium chloride. You will also get the same product, RCO R dash. ये R dash यहाँ आ जाएगी और क्लोरीन यहाँ से CD के पास आके CdCl2 बनाएगी. It will form cadmium chloride. You can get ketone. So if you are asked question like this, RCOH, carboxylic acid, PCl5A, and then this is your Lindlar's catalyst, this is B, and if you put dimethyl dialkyl cadmium R2CD, if I take particular example, acetic acid, this is acetic acid, gives you on reaction with the PCl5 gives A on reaction with the Lindlar's catalyst gives you B, and A on reaction with the dialkyl cadmium or dimethyl cadmium gives you C. What is C? You just think of what are the possible answers, and we will discuss about it. Now you just tell me what is its answer. कर लिए, देखो आंसर क्या होगा. तो PCl5 means it converts OH to Cl, means you get acetyl chloride, right? You get acetyl chloride, that is A is your acetyl chloride. Lindlar's catalyst means partial reduction, and you get acetaldehyde. So this is your acetaldehyde, right? So B is your acetaldehyde. When you are using dialkyl cadmium, means here dialkyl cadmium, that is you get ketone, that is you get acetone. So it is your C, right? So this is your C. In this way, you can get its answer, and if questions are likely to come in the CHS examinations, and I am hopeful that you can answer all the questions. Next is your Stephen's reduction. Stephen's reduction by Stephen's reduction. What is Stephen's? This reduction was asked in 2018 CHSE examination. What is that reduction process? When alkyl cyanide is partially reduced with stannous chloride and a concentrated HCl, then the product is hydrolyzed in acidic condition. We get aldehyde. You cannot prepare ketone in this process. How it takes place? Stannous chloride on reaction with the HCl, it produces nascent hydrogen, SnCl4 plus 2H. SnCl4 plus 2H. And this RC triple bond N, here there is a triple bond between carbon and nitrogen. There are 2 pi bonds, and 1 pi bond breaks by the nascent hydrogen, and we get here a pi bond breaks, 1 hydrogen is added here, another is added here, we get imine RCH. So RCH a double bond NH. This is your imine. And this imine upon hydrolysis in acidic condition, you see you break this bond, put O here and H2 here. H2. In this way the bond breaks and we get aldehyde, right? And this is your ammonia or NH4 plus, because medium is acidic. You will get ammonium chloride. So this is the best method of preparation of aldehydes only, and you cannot prepare any ketone by this method, right? Another is a very important method, that is your ozonolysis. Ozonolysis, it is such a beautiful method. This method is used for determining the position of a double bond. By this method we can prepare aldehydes and ketones from alkene, and also we can determine the exact position of a double bond in alkene, right? So let us see. Alkene, this is alkene. I am just writing the how to write the reactions and how to get the products. I am going to tell you the tricks. So this is your alkene. I am not mentioning here the groups. It can be any group like alkyl or hydrogen. And when treated with ozone in ether medium at 0 degrees Celsius or low temperature, you can, because ozone is unstable at high temperature, you have to maintain low temperature. How to write? What are the intermediate? While making intermediate, ये देखो, ये डबल बॉन्ड को उखाड़ के फेंक दो, ये रहा C और ये रहा C। इन ओजोन यू हैव 3 ऑक्सीजन एटम्स, कैसे लिखना है? यू ब्रिंग 1 ऑक्सीजन ओवर हियर, 1 ऑक्सीजन, इसके नीचे एक ऑक्सीजन और इसके नीचे एक ऑक्सीजन और दोनों के बीच में एक ऑक्सीजन रख दो और उनको कंबाइन करो, उसको कहते हैं ओजोनाइड। दिस इज अनस्टेबल, हाईली अनस्टेबल, and this ozonide undergoes reductive cleavage. It undergoes reductive cleavage because it is so unstable, that is why it is called working up with the ozonide under reduction condition. What are the reducing agent? Remember, it is zinc in presence of water or dimethyl sulfide. You have to use these reducing agents. You cannot use oxidizing agents. मैं अभी बताऊंगा कि ऑक्सीडाइजिंग एजेंट यूज करने से क्या होने वाला है। सो दिस बॉन्ड ब्रेक्स हियर, द बॉन्ड ब्रेक्स लाइक दिस, सो मीन्स दिस हाफ बॉन्ड दे मेक ए डबल बॉन्ड हियर। यू सी दिस इज द कार्बोनिल formed from this portion, and this double bond, another double bond carbon also makes C double bond O like this. You look into the reactant and product, what you observe, क्या देख रहे हो? जिस कार्बन के बीच में डबल बॉन्ड था वो कार्बन आखिर क्या हो गया? यहाँ पे डबल बॉन्ड आ गया, यहाँ पे डबल बॉन्ड आ गया, ये टूट गया, राइट? ये रहा प्रोडक्ट। तो अगर तुमको इफ यू आर गिवन the aldehydes or ketones and asked what are the original alkene, you can also write this was the original alkene. If alkene is given and you are asked what are the products of ozonlysis products, you can also write, you remove this and you put double bond O double bond here like this. Now you answer me, if I take this is the alkene, okay, I do ozonlysis, जिंक की reductive cleavage मैंने किया, what will be the products? What are the products? How will you write? Just remove this double bond. Just remove the double bond, CH3CH, CH2. Make it a double bond O, make it a double bond O. Okay? What is it? Acetaldehyde. What is this one? Formaldehyde. Similarly, if you are given like this, and if you are given a compound Bu2 and Bu2 जैसे मैंने अभी कहा था कि ये रिएक्शन सिर्फ एल्डिहाइड और कीटोन इस रिएक्शन से हम नहीं बनाते हैं, इस रिएक्शन से दूसरा बहुत इंपॉर्टेंट बात है कि डबल बॉन्ड का पोजीशन हम डिटरमिन कर सकते हैं इसी से। देखो, तुमको दिया गया Bu2 और Bu2 ये पूछा गया कि टेस्ट करके बताओ which one is Bu2 and which one is Bu2 both shows unsaturation test, both shows unsaturation test। क्या करोगे? ओनली ओजोनलिसिस करना, ओजोनलिसिस, जिंक वाटर दे दो, ठीक है? क्या बनेगा यहाँ पे? उसको तोड़ दो, यहाँ पे डबल बॉन्ड O, यहाँ डबल बॉन्ड O लगा दो, क्या हो गया तुम्हारा? एसिटाल्डिहाइड और एसिटाल्डिहाइड। जिस अल्किन ने सिर्फ एसिटाल्डिहाइड बनाया वो समझो Bu2 ही था। और यहां से क्या बनेगा? देखो, इसको भी ओजोनलिसिस करो, डू द सेम रिएक्शन। बाकी जो प्रोसेस है ना उसको सिर्फ लिखना का फॉर्मेलिटी है, पहले सीखो कि प्रोडक्ट क्या बनने वाला है, वो ट्रिक मैं बता रहा हूं। तो यहां उसको तोड़ दो, डबल बॉन्ड O लोग यहां कर दो, या डबल बॉन्ड, मतलब ये फॉर्माल्डिहाइड यहां से बना प्रोपेनॉल्डिहाइड। ये रहा ट्रिक, ठीक है? इफ यू आर आस्क्ड व्हाट विल बी द ओरिजिनल अल्कीन which upon ozonlysis produces acetaldehyde and acetone and acetaldehyde. If these are the ozonlysis product, what was the original alkene? अगर ये पूछा गया तो कैसे लिखोगे? देखो, ये जो CO उसको इसी तरह लिखना, CO, और ये CH3 लिख देना। जितना एल्डिहाइड कीटोन आपको मिल रहा है ओजोनलिसिस प्रोडक्ट से उसको उसी तरह ही लिखना, CO इसी तरफ से लिख दो। और ये जो दूसरा कंपाउंड का CO, you just write in this way, here you have H, you have CH3। रिवर्स की ओर से हम जा रहे हैं, रिवर्स प्रोसेस में जा रहे हैं। देखो, ये O को हटा दो, O को हटा दो और दोनों के बीच में डबल बॉन्ड लगा दो, ये था तुम्हारा ओरिजिनल अल्कीन। अगर नाम ठीक से नहीं लिख पाए तो कोई बात नहीं, स्ट्रक्चर कम से कम ठीक है आ जाएगा। here original alkene, which on ozone-less produces this one, right. So, this is very, very important. Another thing is, if you add, instead of a reducing agent, if you add hydrogen peroxide or oxidizing agent, that will give you oxidative cleavage, means you may get ketone or acid. For example, if I take double bond, means here you have R, here R, you have R, here you have H. Remember this one. Similarly, you will get ozonide, R and H. If you add any oxidizing agent instead of a reducing agent like zinc and a water or dimethyl sulfide, you will get जो H है, it will give you acid. This H will be converted to acid and this will give you ketone. So, that means you will get ketone, and here this portion gives you ketone and this portion will give you carboxylic acid, RCOOH. This is the difference. So, be careful when you are doing decomposition of ozonide by using suitable reducing agent. कभी हाइड्रोजन पेरोक्साइड मत लिखना, सिर्फ जिंक वाटर और डाइमिथाइल सल्फाइड ही लिखना, ठीक है, ये बहुत इंपॉर्टेंट है. और नेक्स्ट अनदर मेथड ऑफ प्रिपरेशन इज योर फ्रॉम अल्काइन, राइट. फ्रॉम अल्काइन, देखो फ्रॉम अल्काइन देयर आर टू प्रोसेसेस ऑफ प्रिपेयरिंग, फ्रॉम अल्काइन देयर आर टू प्रोसेसेस ऑफ प्रिपेयरिंग योर aldehydes or ketones. Number one, from alkynes. There are two methods. Number one is your catalytic hydration, number one. Number two is your hydration by acid mixture of mercuric sulfate. These are the two different types of reagents. By using, we can prepare aldehydes or ketones from alkynes. How? You just see catalytic hydration. So, catalytic hydration means if you take alkyne like this and you add water in presence of dilute sulfuric acid, this is your catalyst. This is symmetrical I have taken. For example, if I take but2-YNE, particular example I am taking here, but2-YNE, but2-YNE. So, here what happens, the acid facilitates the addition of water across this triple bond. One pi bond breaks, H and OH. H is added at one carbon, OH group is added to another carbon. Like this, you get CH3, C, here you have a double bond C. First you write, breaking the pi bond, you write the remaining structure and then you put H over here and OH over here, right. So, this is your enol. So, this forms your enol, okay. And enol, you know, is converted to its isomeric form, that is ketone. It is converted to your another isomeric form. Here H, कल मैंने बताया था कि ये जो O के पास जो H है, ये H डबल बॉन्ड के पास जो ये कार्बन इसके पास आ जाएगा और यहाँ डबल बॉन्ड बन जाएगा और ये डबल बॉन्ड टूट जाएगा. तो क्या बनेगा, CH3, ये H यहाँ से यहाँ आ जाने से क्या बनता है, CH2 और CO CH3. दैट मीन्स यू विल गेट कीटोन. In this process, you cannot prepare aldehyde. In this process, you cannot get aldehyde. Okay. Similarly, because you see, if you take one alkyne CH3C triple bond CH, if you take this molecule and if you think of doing catalytic hydration by using dilute sulfuric acid, it will not give you the product, because the terminal alkynes are less reactive. Terminal alkynes are less reactive towards catalytic hydration. Only जो ट्रिपल बॉन्ड मॉलिक्यूल के अंदर में जितना अंदर में होगा वो ही रिएक्शन करेगा. अगर वो बाहर में आ जाता है, टर्मिनल पोजीशन पे आ जाता है, तो इतना उसका जो रिएक्टिविटी वो घट जाती है. तो so you cannot get the product here, right? But if you do the reaction using mercuric sulfate and a dilute sulfuric acid, you can prepare ketones and also aldehydes by using these reagents. देखो, if I take acetylene, and add water, the catalyst here is a dilute sulfuric acid and mercuric sulfate. So you get HC double bond CH, here you have H1OH. So this is called enol, and enol is tautomerized to give you ketone, and you will get acetaldehyde. So from acetylene you will get acetaldehyde. Okay. Now let us discuss about the mechanism how the mercury cation catalyzes the addition of water across the triple bond of alkene and prepares your or forms your aldehyde or ketone. So let's have a look. So this is your triple bond. Here it is a triple bond. Here I have taken hydrogen, and you know mercury cation, it belongs to it is a transition metal, and its 5d orbitals are fully filled. So zinc, cadmium, mercury, all of these metals, you know, their d orbitals are fully filled, and it has double positive charge. So it donates its 1 electron pair from 5d orbital. Okay, it donates electron pair to this carbon or any carbon, and then takes away 2 electrons to itself, because its 6s orbital is vacant, because it has already donated 2 electrons to someone. ठीक है, 2 इलेक्ट्रॉन 5d से दे रहा है और यहाँ से ले रहा है. ठीक है, दैट मीन्स इट फॉर्म्स ए साइक्लिक इंटरमीडिएट लाइक दिस C double bond C और Hg2 plus. ठीक है. Now this as it withdraws electron density from the triple bond, so these 2 carbon atoms are becoming electrophilic, and water attacks the molecule as a nucleophile. From this side, where R is present, from this side it attacks, and this makes a bond with this one, and this bond breaks, and we get intermediate like this C, here O, H, you have a plus over here, and this is your double bond C, here you have H and Hg plus. Okay. Now this loses a proton, deprotonation, we get Rc, this is OH, right? This is your OH, and double bond C, this is H, this is Hg plus. Now it exists in tautomeric form, it undergoes tautomerization to form this ketonic compound Rc, double bond O, this is a double bond O. Now C, H, and this is Hg plus. You see, mercury as a catalyst, it cannot stay in the molecule for longer period of time, so it will have to leave the system. So it again transfers 2 electron, and here since you are using dilute sulfuric acid, that means we have enough H plus, that means acidic water, and when it donates the electron to shifts the electrons to this one, so the 2 electrons shifted to oxygen, and then it abstracts the proton. That means we get another enol compound like R, C, OH, double bond C, H2. So mercury is lost as mercury cation. Again we get enol, and that enol is tautomerized to give you ketone. So RCO CH3, right? So in this way your mercury catalyzes the addition of water to alkyne, and we get aldehyde or ketone. So many times it has been asked in the examination how will you prepare or what happens when acetylene is treated with dilute sulfuric acid in presence of mercury sulfate. What is your answer? You just simply add H at one side and OH on the other side, right? And this is enol and enol is tautomerized, you will get acetaldehyde. So this is the answer. What happens when propane is treated with 40% H2SO4 in presence of HgSO4. So many times this question has been asked in CHS examination. What will be your answer? You just break the pi bond here. So CH3, C. From this side you add OH and double bond CHH. जिस साइड में अल्किल ग्रुप है उसी साइड में OH डालना, ठीक है. नेक्स्ट इट इज tautomerized, it undergoes isomerization, that is tautomerization, and it will give you ketone, right? So these are the questions that have been frequently asked in CHS examination. Another preparation is from geminal dihalide. From geminal dihalide, how will you prepare aldehyde? Just have a look. And a ketone also. You can prepare ketone. Geminal dihalide means if any organic compounds contain two halogen groups bonded to if two halogen groups are bonded to same carbon atom, then it is called geminal dihalide. When geminal dihalide, this is called geminal dihalide, right? So geminal dihalide, when treated with the aqueous KOH, you know, nucleophilic substitution reaction, OH comes, X goes out, here another KOH, you have to take two equivalent amount of KOH, another OH attacks, X is out. So we get RC, OH, here I can bring R to this position so that it can be conveniently shown how the product is formed. So since the carbon contains two OH group, it is unstable and immediately it loses a molecule of water and we get ketone, right? Similarly, if you take this compound 1,1-dichloroethane, if you take 1,1-dichloroethane and if you treat it with the aqueous KOH, what will be the product? See, CH3, CH, OH, and this is your OH. So this is unstable, immediately loses a molecule of water and give you acetaldehyde. So the product is your acetaldehyde. Okay. Now let us discuss some questions that has been frequently asked. So the question is, what happens when calcium acetate and calcium formate are dry distilled? What happens when calcium acetate is dry distilled? And how will you get formaldehyde from formic acid? How will you get formaldehyde from formic acid? So these are the questions so many times they have been asked in CHEC and other examinations. What are the answers? You know, when mixture of calcium acetate and calcium formate are dry distilled, we get mixture of three products. What are the products? From this one you get acetone. And from this one you get formaldehyde. I have already discussed. And of course acetaldehyde. So I get a mixture of three products. They are very difficult to separate because of closure of boiling points. Here you get only formaldehyde. So I have already told you this is the suitable method only for preparation of formaldehyde, not for the other aldehydes. Okay? And this one, how will you get this one? So this is your formic acid. So you react it with the SOCl2, right? Then you will get formyl chloride, but this is not suitable method. Do Rosenmund reduction, you will get a formaldehyde, but this is not suitable method. Let me tell you, because formyl chloride is highly unstable and poisonous. Another method is there. How can you convert this one? You do the reduction with lithium aluminum hydride, you will get methyl alcohol, right? Here it is only one carbon, you will get methyl alcohol, and a methyl alcohol आज मैंने पढ़ाया, you can use PCC or PDC or Collins reagent or Swern's reaction, do Swern's reaction, you will get this aldehyde compound. So these are the questions frequently asked in CHEC examinations. ठीक है? I am hopeful that in today's discussion, in today's class, you have been highly benefited and you have learnt lots of things. The important things I have already discussed, and I am sure whatever questions are likely to come in the coming CHEC examinations, you will feel comfortable to answer all the questions, and you will find no difficulty in answering any questions in the coming CHEC examinations. So, thank you for attending the class and till the end. Thank you very much.